In this video, let us study about half subtractor. First, we will see what is a half subtractor. Then, we will look at its block diagram, working, truth table and logic diagram. Let us start. So, what is a half subtractor? A half subtractor is a combinational circuit which subtracts two 1-bit numbers and produces two outputs. These two outputs are difference and borrow. So by using this definition of a half subtractor, we can draw its block diagram. Consider this block and assume that inside this block there is some logic which performs the operation of half subtractor. That is, it takes two inputs x and y and it produces two outputs difference and borrow. So this will be your block diagram of a half subtractor. Next, let us see the truth table of half subtractor. So we had two inputs x and y, two outputs d and b. D is difference and b is borrow. So for two inputs we will have 2 power n input combinations, that is 4. So it will be starting from 0 0 and ending at 1 1. The difference output is got by subtracting y from x, and this borrow output indicates if you have taken a borrow from the higher bit. So for input 0 0, difference is 0 and borrow is 0. So if you subtract 0 from 0, the difference is 0, and since you do not need any borrow from the higher bit, b will also be 0. Now for next input 0 1, when you subtract 1 from 0, difference is 1 and borrow is 1, since you require a borrow to be taken from the higher bit. For input combination 1 0, 1 minus 0 would give you 1 as the difference, and borrow is 0 since you do not need any borrow taken from the higher bit. For last input combination 1 1, difference is 0, that is 1 minus 1 is 0, and borrow is also 0 because you do not need a borrow from any higher bit. So this was your truth table of a half subtractor. The working of a half subtractor is nothing but just explaining what is there in the truth table in words. So the working is when x is 0, y is 0, then difference is 0 and borrow is 0. Similarly, when x is 0 and y is 1, then difference is 1 and borrow is also 1. When x is 1 and y is 0, then difference is 1 and borrow is 0. When x is 1, y is 1, then difference is 0 and borrow is also 0. Now to draw the logic diagram of a half subtractor, we have to know the output expression of difference and borrow. This can be gotten by constructing a K-map and simplifying it. For difference, since there are two inputs, we will have 4 input combinations. So let us draw a K-map and enter the value of D for each of the input combination. So along the row we have taken X and along the column we have taken Y. For input 0 0, D is 0, and for input 0 1, D is 1, 0 1, D is 1. For input 1 0, D is 1. So this is your X is 1, Y is 0. So D is 1 here. And for last input combination 1 1, X is 1, Y is 1 and D is 0. So you can see that you cannot form a quad or a pair here. So you will have to group them as single. So now this single expression is X is 0, Y is 1, which means it will be X bar Y. And for this cell, it will be X Y bar. So the output expression for difference is X bar Y or X or Y, which is nothing but X XOR Y. Similarly, for borrow, you will have 4 cells So for input combination 0, 0, borrow is 0, x is 0, y is 0, borrow is 0 here. So for input combination 0, 1, borrow is 1. For input combination 1, 0, borrow is 0. For input combination 1, 1, borrow is 0. So now there is only one 1 here. So we'll have to group it as a single. And the expression for this will be x bar y. So the output expression for borrow is x bar y. Now we have got the output expression for difference and borrow. So we just need to use the basic gate and draw the logic diagram of a half subtractor. So we have two inputs, x and y. So the difference was x XOR y. So this is your XOR gate, and your borrow was x bar and y. So this is your output of a NOT gate. So this will be x bar, and this is y, which is given as an input to an AND gate. So this output will be x bar y, and this is x XOR y, which is your difference, and this is your borrow. So in the next video, let us look at full subtractor. Thank you.